Hello everybody and welcome to your Day 3 notes of the Logic Unit in Geometry. As usual, I want you to start out by doing your warm-up. So at this point, pause the video, do the warm-up, and then come back and check your answers. Okay, now that you're ready to check your answers, number one, if possible, we want to use the law of syllogism to write a new conditional statement that follows from the pair of true statements. First statement says, if the sun is out today, then Matt will go to the pool. Next we have, if Matt goes to the pool, then he will go swimming. We can see Matt will go to the pool's conclusion of that statement and the hypothesis of this statement, so they cancel each other out, and we have, if the sun is out today, then Matt will go swimming. Next we want to use the law of detachment to make a valid conclusion given the following statements. In the winter, the sun rises after 7 a.m. It is December. What can we conclude there? That the sun will rise after 7 a.m. Next, we want to use this conditional statement and find the converse, inverse, and contrapositive. The original statement is, if you are out of milk, then you will go to the store. The converse of that statement, and hopefully you remember the converse, we're just flipping the hypothesis and conclusion, will give you, if you go to the store, you are out of milk. That statement was actually, if you go to the store, then you are out of milk. The inverse of our original statement, and remember we're going to negate the hypothesis and conclusion, would be, if you are not out of milk, then you do not go to the store. You may have written there, if you have milk, then you do not go to the store. That would work as well. Contrapositive, we're going to flip and negate and be left with the statement, if you do not go to the store, then you are not out of milk. Next, a biconditional statement must contain what phrase? Hopefully you all remember that phrase is, if and only if. Number 5, we need to find a counterexample to the statement, all three-sided figures have at least one 90-degree angle. Your answers may vary here, but I've given you an example of what looks like it might be an equilateral triangle, but it's definitely an acute triangle. You can see all the angles are less than 90 degrees, and it is in fact a three-sided figure. Number 6 asks you to sketch the next figure in this sequence. You can see we've got squares. The circle appears to be moving in this direction. So the next figure would look like this. Now we're going to talk about symbolic notation. Before we talk about symbolic notation, let's recall what we know about conditional statements. Given the conditional statement, if Peggy rides her bike, then she will wear her helmet, we want to find the following. The converse of that statement, again, we're just going to flip the hypothesis and conclusion and get, if Peggy wears her helmet, then she rides her bike. The inverse of that statement, we're going to negate the original hypothesis and conclusion and get, if Peggy does not ride her bike, then she will not wear her helmet. And for the contrapositive, again, you want to flip and negate, and you'll be left with, if Peggy does not wear her helmet, then she does not ride her bike. Symbolic notation, as I'll tell you guys several times throughout the year, mathematicians are lazy. And we don't want to write out all these big words, so we've come up with abbreviations for almost anything. So for a conditional statement, if our conditional statement was if P then Q, we could just write P arrow Q, or that would read as P implies Q. The converse of that statement, then, we would just flip the hypothesis and conclusion and get if Q then P, or Q implies P. To do the inverse, we're going to put this symbol in front. That's the negation symbol. So this says if not P, then not Q, and that's the way we would read this. If not, or not P implies not Q. For the contrapositive, we flip and negate, so we have if not Q, then not P, which would read as not Q implies not P. And the biconditional, which we would say is P if and only if Q, we would write with a double-headed arrow, and this would be P if and only if Q. What's not written here is the 3 dots in the triangular pattern means therefore. You'll see that when we're doing the law of syllogism or law of detachment. We'll use the therefore symbol to let you know that that's a conclusion coming. So let's take a look at an example here. We're going to let P represent the car is running, and Q is the key is in the ignition. So we want to write in words what the statement P implies Q would be. So we're just going to substitute in, and we would have, if the car is running, then the key is in the ignition. The converse of that statement, or Q implies P, written out in words would be, if the key is in the ignition, then the car is running. The inverse of the original conditional statement, or not P implies not Q, would be, if the car is not running, then the key is not in the ignition. And statement number 4, the contrapositive, not Q implies not P, would be, if the key is not in the ignition, then the car is not running. Another thing to talk about with conditional statements is the truth table, or the truth values of a conditional statement. The truth value is the truth or falsity of a statement. That's basically is the statement true or is the statement false. A truth table is a table that shows the truth values for a hypothesis, a conclusion, and a conditional statement. There's an example of the truth table. We're going to look at this statement. If you get an A, then I will give you $5. Okay, in this particular example, if the hypothesis is true and the conclusion is true, then the whole statement is true. So if you do get an A and I give you $5, then that's a true statement. The next thing we can look at, if the first part of the statement or the hypothesis is true and the conclusion is false, then the whole statement would be false. An example would be, you got your A and then I didn't give you $5. Well, then this original statement is false. Third example we could have, if the hypothesis is false but the conclusion is true, that still might mean the whole statement is true. So for example, if you didn't get an A, but I would have given you $5 if you did, then that statement is still true. And finally, if the hypothesis is false and the conclusion is false, that makes the statement true. I know that doesn't make a lot of sense, but if you look at it, if you did not, so we have here if you get an A. Let's say you got a C, which you wouldn't get in geometry, but hypothetically. If you got a C and you didn't get $5, that doesn't mean the statement is false because you didn't meet your end of the bargain. One important thing to know when we talk about the different statements we have, the contrapositive is going to have the same truth value as the conditional statement, and an inverse is going to have the same truth value as a converse. So if you have a true conditional statement, the contrapositive will also be true. And if you have a true inverse, the converse will also be true. Same would be said if they were false. I hope you enjoyed today's lesson, and I will see you in class.